This is the second video for Chapter 8 notes. 8.2 is testing a claim about a proportion. Remember that the best point estimate of P, the proportion of the population with a certain characteristic, is given by X is going to be the number of individuals in the sample with a certain characteristic, and N is going to be our sample size. And then we have P hat, which is going to be X over N. It is approximately normal with a mean mu equals P and a standard deviation equals the square root of P times 1 minus P all over N if the following requirements are satisfied. So there's three things that you need to check. The first one's going to be that it is a simple random sample. And again, you can abbreviate this SRS. The second thing is that the conditions for the binomial distribution are satisfied. And there's four things here that you need to check. So 4 items to check. And again, those four things are going to be that you have a fixed number of trials, the trials are independent, you have a fixed probability, and that there's two mutually exclusive outcomes. And then N times P and N times Q are both greater than or equal to 5. Our test statistic, which again, we're going to be using a graphing calculator to calculate, is given. And so on the top of the next page, it says testing the hypothesis regarding a population proportion using the p-value method with a TI-83 or 84 graphing calculator. So again, you first need to make sure the requirements to perform the test are met. Those are just talked about right up above. And so definitely make sure to check those unless otherwise stated that they've already been met. Then step 1 says determine the null and the alternative hypotheses. And you'll notice that H naught is the same for all three cases, a two-tailed, left-tailed, right-tailed test, and then H1 is going to change depending on that type of test that we have. Second step says to select a level of significance, alpha. This is usually given to us in the problem. Step 3 is going to be to find our p-value and test statistic. If necessary, enter your raw data into L1. And so we are going to go to stats, the stat button on our calculator, to test. And from there, you need to go to number 5, which is 1 prop Z test. And again, if this is something different on your calculator, make sure to edit these notes so it fits correctly for your type of calculator or app. You need to put in X, which is the number of successes, and N, which is our sample size. I did put a screenshot over here of what the graphing calculator with the TI-84 would look like. And again, all of the versions are a tad different. So again, adjust it to make sure that it looks like what you see on your specific calculator or app. And then you're going to select the direction of the alternative hypothesis. It's either not equals to, less than, or greater than. And you can see that on here. And you're just going to select one. Then you're going to highlight calculator draw and press enter. So calculate is going to give us our test statistic, which is Z, and P, which is our p-value. Step 4 says if the p-value is less than alpha, then we reject the null hypothesis. And then step 5 is going to be to state our conclusions. And remember, we did that up above in our previous section. So the first example here says test the hypothesis using the p-value approach with H1 being p is less than 0.34. And then they also give us that N is equal to 250, X is equal to 75, and alpha is equal to 0.10. So the first thing we need to check is going to be our requirements. And the first thing we are going to assume, this is a simple random sample. This is a very simple example that we're going through because it doesn't have all the words. And so it's difficult to really get a sense of what's going on. This is more or less for us to get used to checking everything, what we need to check, and how to actually use the graphing calculator. Step 2 is going to be making sure that your 4 conditions for the binomial are met. So we have 250 trials. We're going to assume that they are independent trials. We have a fixed probability, which is going to be the 75 over 250. When you divide this, you get 0.3. And then the last thing is that we have 2 outcomes. The third requirement that we need to check is going to be that N times P and N times Q are both going to be greater than or equal to 5. So again, N is 250. P, we calculated up above, is 0.3. And then remember, Q is going to be 1 minus P, which is 1 minus 0.3, which is 0.7. Working both of these out on your calculator, we get 75 for the first one, which is greater than or equal to 5, so check. And the second one, we get 175, which is also greater than or equal to 5, so check. So all the requirements have been met in order to test this proportion. So the next thing that we have is we need to state what H0 and H1 are. And we are dealing with proportions. They do tell us H1, so I'm going to go ahead and put that in. So P is less than 0.34. Your null is going to also be proportions. That number would also be the same, so the 0.34, and your null always has an equal sign. So to calculate this, we are going to use one prop Z test. On your graphing calculator, you need to go to Stat, Test, one prop Z test. P0 that you need to enter in is 0.34. X is equal to 75, N is equal to 250, and then also make sure that you select left-tailed, that less than symbol, since this is a left-tailed test. From here, you get your P calculator. We get a P value equal to 0.0909, and we need to compare this to our alpha value, which was given as 0.10, and that was given to us up above. And since our P value is less than our alpha, this means that we are going to reject H0. So we're rejecting our null. So the next thing that we need to do is write our conclusion, and we practiced this in the last section. So this is going to start with there is sufficient evidence at the alpha equals 0.10 level of significance. And really quick, this is important to include in your conclusions, because if, for example, if our alpha value was something different like 0.05 or 0.01, we would have had a different conclusion. So to conclude that, and again, whenever you write your conclusions, you always talk about H1, which is going to be that the proportion is less than 0.34. So at the top of the next page, we have a word problem using the same techniques. And so for this one, it says the drug Lipitor is meant to reduce the total cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking a competing drug complained of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect? Let alpha equals 0.01 level of significance and assume that the testing criteria has been met. So since the testing criteria has been met, we do not need to check those requirements. Instead, we're able to just go ahead and start this problem with our H0 and our H1. So before we start writing things down, the first thing that we want to note is that we are dealing with a percentage here. It's 1.9% of patients taking this drug complained of flu-like symptoms. And so that's for our population. Our sample is going to be 19 out of 863. So that means that X is equal to 19 that have those flu-like symptoms, and N is equal to 863. So since we're dealing with percents, that's a proportion. So I'm going to write down P for both H0 and H1. Our null always has an equal sign, and we're dealing with our population of 1.9%. Writing that as a decimal, we get 0.019. So the same number is going to be in both H0 and H1. Now, figuring out the symbol to use on H1, you need to be careful and read the problem. And it does say that they are checking to see if more than 1.9%, so that would be greater than. And so for this, we are going to also use one prop Z test. Graphing calculator, you're going to go Stat, test, 1 prop z test. Your p naught value that you're going to enter in is 0.019. Select enter. X is 19. So type 19 and select enter. And in our sample size is 863. Select enter. Also, this is a right tail test, so make sure you select that greater than symbol there, and you should get your p-value given to you on your graphing calculator. From the graphing calculator, we get a p-value equal to 0.2582, and we are going to compare this to alpha, which is equal to 0.01, and so this is greater than alpha, which means that we do not reject H naught. So from here we do need to write our conclusion. And so this time we're going to start off with there is not sufficient evidence and we'll say at the alpha equals 0.01 level of significance to conclude that, and again, we always talk about H1, and H1 here is that P is greater than 0.019, but what this was talking about for this problem, you need to make sure that you explain it with words that talk about exactly what the problem is representing. So to conclude that more than 1.9% of Lipitor users experience flu-like symptoms. So again, H1 is always what you talk about in your conclusions, since that is what you are testing. So the next example that we have says data collected on M&Ms lists 100 M&Ms and 34% of them are blue. The Mars Candy Company claims that the percentage of blue M&Ms is equal to 24%. Uses 0.05 significance level to test the claim. Should the Mars Company take corrective action? So the first thing is that we have a sample of 100 M&Ms and 34% of them are blue. And then we also are testing at a 0.05 level significance to see if the percentage of blue M&Ms is equal to 24%. So checking our requirements, the first thing is that this is a simple random sample since we're just dealing with M&Ms. We have 100 trials. These trials are independent. We have a fixed probability. And this is equal to 0.24. And we have 2 outcomes. And the 2 outcomes for this case are going to be they're either a blue M&M or not blue, since that's the only color that we're dealing with. The next thing that we need to check is that N times P and N times Q are both greater than or equal to 5. So N is 100. Our probability is 0.24. And so 1 minus 0.24 is 0.76. So working this out, we get 24 is greater than or equal to 5. And 76 is greater than or equal to 5. So check for both of those. On the graphing calculator, we are going to use 1 prop z test. And for this, we need to set up our null and alternative before we can actually conduct our test. So since we are dealing with percentages, again, that's another word to use for proportions. We are going to use the percentage that the company is claiming, which is at 0.24. So putting that down for both our null and alternative. Remember, our null always gets an equal sign. And then for our alternative, you will see that it doesn't explicitly say anything about being greater than or less than. Do not read it as 34% is more and make an assumption that that was what the researcher was thinking. If it does not clearly state more or less, then we are going to use not equals to. Calculator, you're going to go to stat, test, 1 prop z test, our P naught is going to be that 0.24. N is 100. And then how to get 34 is you multiply 34% or 0.34 times 100. And that gives you 34. Also make sure to select two-tailed test for this. And you will see your p-value there. Make sure to round it 4 decimal places. From the graphing calculator, we get a p-value equal to 0.0192, and we need to compare this to alpha, which is 0.05. So our p-value for this case is less than alpha, which means that we are going to reject H naught. So from here we need to write our conclusion, and we're going to say there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that, and again we always talk about H1, so that the proportion of blue M&Ms is different than 24%, or you can write as 0.24. And so this also asks, should the Mars company take corrective action? And since we're rejecting our null, which was that the proportion is equal to 0.24, it is showing that from this sample, which isn't very large, we should actually be collecting more data to kind of prove this if we want to have a case to go against the Mars company, but that it is not equals to, and that there is an issue with the amount of blue M&Ms that are in these bags. So we have another example right below this. And this one says, this question was posed to the American online website, do you believe in the Loch Ness Monster existing? So among 21,346 responses, 64% were yes. Use a 0.1 level of significance to test the claim that the majority of people believe in the Loch Ness Monster. Use the confidence interval approach. So we're going to use a different approach this time. And assume that all criteria has been met. So again, all of our criteria has been met, so this means that we do not need to check those requirements. One of the new things on here is that it doesn't give me a percent, it uses a word instead. So this is majority. And so majority, what this means is more than 50%. So more than half would be a majority. And so reading this again, we have quite a few responses, so 21,346. 64% of them said yes. They believe in the Loch Ness Monster existing. So first thing here we're going to do is write down our null and our alternative. And since we're dealing with a majority here, we do have a percentage. So we're going to go to use proportions. And since we're dealing with a majority, it's going to be 0.5 for both of these. Our null is equal to, and majority is more than 50%, so put a greater than symbol in here. It does want us to use our confidence interval approach, and so we learned about confidence intervals back in chapter 7. And one of the key things here is that when you set this up, you'll notice that this is a right-tailed test. And so that means in the right tail over here, I'm going to put my alpha, and alpha is equal to 0.01, and that was given to us. But whenever we do hypothesis testing using a confidence interval, we do need to set this up as a two-tailed test. So your confidence interval approach, you need to set up as two-tailed test. So from here, I need to draw another line over here, and because of the symmetry, this is also going to be equal to the 0.01. So those two tails should be the same. Remember, the total area under your curve is equal to 1. So subtracting 0.1 and 0.1, we do get a 98% confidence level. So this is going to be our C level, is equal to 21,346 people that were given this survey. In order to calculate the number of people that do believe in the Loch Ness Monster, we need to take our sample size, which is 21,346, times the 64% that responded yes. And then when doing this, we get 13,661 people that did believe in the Loch Ness Monster that responded to the survey. On your graphing calculator, you're going to go to Stat, Test, and since this one wants us to use the confidence interval approach, I'm going to find one prop z int. From here, x we calculated as 13661, enter. And our sample size was 21,346, select enter. And our sea level again is that 0.98 and select enter. From here, you're going to get a lower and an upper bound. And so go ahead and round those 3 decimal places. From the graphing calculator, we get an interval of 0.632 and an upper bound of 0.648. And so you need to check to see if that value that you had in your hypotheses is in this interval. And you'll notice that 0.5 is not in the confidence interval. So since it's not in there, we are going to reject H naught. And so from here, we can say that there is not sufficient evidence at the alpha equals 0.01 level of significance to conclude that a majority of people believe in the Loch Ness Monster. So at the top of the next page is section 8.3, and this is testing a claim about a mean. So again, 8.1 was introducing us to this idea, 8.2 is testing a proportion, and now in 8.3 we're going to be testing a mean. So it says, it is very rare that we test a claim about an unknown value of a population mu, but we somehow know the value of the population standard deviation. When the standard deviation of a population is unknown, the test statistic has a distribution called the student's t distribution, and the test statistic is going to be given by the formula that is typed here. However, I want you to understand that we are using a graphing calculator, and this formula is not going to be used to calculate it by hand. We're going to be using our graphing calculator. So right below that is our box that goes through how to use our TI 8384, and this is testing a hypothesis regarding a population mean. Again, we use that p-value approach, which is the majority of the way that we are going to be doing these problems. So the first thing is to make sure the requirements to perform the test are met. We have 2 requirements this time that you need to check. The first one is that it is a simple random sample. And the second thing is going to be that our sample is large enough. And large enough for us is going to be greater than or equal to 30. So again, make sure you have that greater than or equal to 30 stated when you check your requirements, and you check to make sure that's true. If it's not greater than or equal to 30, it could still work and we could still do this, but the population has to be normally distributed. So sometimes it will explicitly state this in the problem, and other times you can go through what we did in section 6.5 to verify that the population is normally distributed. So step 1 is to determine our null and alternative hypotheses. And you'll notice that the null is the same for all 3 tests. And then the alternative, your H1, depends on if it's a two-tailed, left-tailed, right-tailed test. Step 2 is to select your level of significance alpha. And again, this is usually given to us. And then step 3 is to find our p-value and test statistic. And so to do this, we're going to go to stat, go to test, and we're going to go to t-test. And so there's 2 options here. You can either have raw data, so that's like a list of numbers. And if you do, you're going to highlight data and you're going to put your numbers into L1 and set the frequency equal to 1. There is a screenshot over here on the left that does show you the data and then also the other option, which is stats. So summary statistics is known. You're going to highlight stats and you're going to enter in all those values that it asks for. Select the direction of the alternative hypotheses. Again, you're going to just select one. It depends on how the problem is written and given to you and what the alternative hypothesis is. And then you're going to highlight calculate, and from there you get our t value, which is our test statistic, and p, which is our p-value. Step 4 is going to be if the p-value is less than alpha, we reject the null hypothesis. This is the same that we have seen in the last section. And then step 5 is going to be to state that conclusion, just like what we did learning about in 8.1. So the example right below says in 2019, the mean height of women 20 years of age or older was 63.7 inches based on data obtained from a CDCI and Prevention's Advanced Data Report number 347. Suppose that a random sample of 45 women who are 20 years of age or older today result in a mean height of 63.9 inches and a standard deviation of 5.5 inches. So the first thing says, are the requirements met to perform this test? So the first one is it needs to be a simple random sample, and it states that. And then the next thing that it says is that we have to have a sample greater than or equal to 30. And so our sample size for this problem is 45 women. So 45, which is greater than or equal to 30. So check. So yes, the requirements are met. Part 2 here says state the appropriate null and alternative hypotheses. So we have H0 and H1. And it does say to assess whether women are taller today. So we are talking about the mean height or the average height. And so we are going to put μ's for both of these. The average height of women from our previous study is 63.7 inches. So that number is going to go for both of these. Again, your null always has an equal sign, and taller today means our alternative would be a greater than symbol. So on the next page, it does say use the p-value approach to test the claim to see if women are taller today. And it says let alpha equal 0.05. So for this, we are going to use our t-test. And so with this, from our sample, we have a sample mean of 63.9, a sample standard deviation of 0.5, and again, our sample size is 45 women that we surveyed. On the graphing calculator, select Stats, go right to Test, and this time we are using t-test. And for this, you'll notice that you can toggle between Data and Stats. Since this one we're given summary statistics, I'm going to leave it on stats. Our mu naught is going to be what we have in our null and our alternative hypotheses, which is the 63.7. X bar, we have a 63.9. Our standard deviation is 0.5. And our sample size n is equal to 45. Also note that this is a right-tailed test, so make sure your greater than symbol is selected. You have your p-value and make sure to round it 4 decimal places. From the graphing calculator, we got a p-value equal to 0.0051, and we're going to compare this to alpha, which is 0.05. And so our p-value is less than alpha, and that means we are going to reject H0. So there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that, and again, H1 was saying that women are taller. So to conclude that women are taller than they were in 2019. So right below this, we have another example. So this example says, do students who learn English as well as another language simultaneously score worse on the SAT critical reading exams than the general population of test takers? The mean score among all test takers for the SAT critical reading is 501. And so that's going to be our population. It says a random sample of 100 test takers who are learning English as well as another language simultaneously had a mean reading score of 485 and a standard deviation of 116. Do these results suggest that students who learn English as well as another language simultaneously score worse on the SAT critical reading exams? So the first thing on here says to verify that the requirements have been met. So the first thing is it's a simple random sample. Whenever you deal with people, they are independent of one another, and it does state that this is a simple random sample of students that were selected. And our sample size N is equal to 100, which is greater than or equal to 30. So check for both of those so we can conduct this test. The next thing that it says is B, use the p-value approach at the alpha equals 0.1 level significance to test the hypothesis in part A. So we're verified this, and what we're asked to find is to see if this is worse for students that are learning multiple languages at one time. So we write down H0 and H1. We are talking about the average or the mean score. So I'm going to put me's for both of these. The number that the general population has for the critical reading exam is 501. Our null is going to be an equals symbol. And then worse than, which is the wording that they used, is going to be less than 501. So to calculate this, we use t-test. On the graphing calculator, we're going to go to stat, test, and again t-test. From here, we're going to enter in our mean, which is 501. X bar, which is 485. SX, which is 116. And our sample size is 100. This is a left-tailed test, so make sure to select left-tailed or less than. From here, you should get your p-value. Again, make sure to round it 4 decimals. From the graphing calculator, we get a p-value equal to 0.0855. And we need to compare this to our alpha value, which is given as 0.1. And so this is less than our alpha value. And so this means that we are going to reject H0. So we next need to write the conclusion. So we're going to say there is sufficient evidence at the alpha equals 0.10 level of significance to conclude that students who learn English and another language simultaneously score worse on the SAT critical reading exam. So right below, so we have another example that says data collected on earthquakes lists earthquakes, depths, and summary statistics are N equals 600, X bar is 5.82 kilometers, and S is equal to 4.93 kilometers. Use a 0.01 significance level to test the claim of a seismologist that these earthquakes are from a population with a mean equal to 5 kilometers. Assume the criteria has been met to perform this test. So for this, we need to list our H0 and H1. And since we're talking about the mean depth, we will write mu for both of these. With the population is equal to 5 kilometers. So I'm going to put 5.00 for both our null and our alternative. The null always gets an equal sign. And that, since it's asking about for being equals to, the opposite of that would be not equals to. So on our calculator, we are going to use t-test. On the graphing calculator, we are going to go to stat, test, to t-test. From here, you need to enter in mu naught is 5. Our mean is given as 5.82, standard deviation is 4.93, and our sample size is 600. Make sure you realize that this is a two-tailed test, so select that not equal option. And you'll notice that our p-value is 5.23884059 negative 5. And remember that E stands for times 10. So this is 5.24 times 10 to the negative 5th. From the graphing calculator, we do get a p-value equal to 5.24 times 10 to the negative 5th. The calculator sometimes rounds a little differently depending on your app or the calculator that you're using. But when we round 4 decimal places, we should all have the same answer. So moving our decimal point 5 places to the left, we get 0.0000524. And then rounding this 4 decimal places, we get 0.000, and the 5 makes the 0 become a 1. And then comparing this to alpha, which for this problem is given as 0.01, we do have that our p-value is less than alpha, so we are going to reject H0. So from here, we need to write our conclusion. And so we're going to start off with there is sufficient evidence at the alpha equals 0.01 level of significance to conclude that the mean depth of earthquakes is, and again talking about H1, so that's different or not equals to than 5 kilometers. So at the top of the next page, we have a few definitions. First one's going to be, we have practical significance, which refers to the idea that while small differences between the statistics and the parameter stated in the null hypothesis are statistically significant, the differences may not be large enough to cause concern or to be considered important. So a key idea here is that large samples can lead to results that are statistically significant, while the differences between the statistic and the parameter in the null hypothesis is not enough to be considered practically significant. So we have another example here that says Michael enrolled in a course that's designed to increase reading speeds. Prior to enrolling in the class, Michael read 198 words per minute. The following data represents the words per minute read for 10 different passages that he read during this course. And so we have a list of numbers there given. Part A says, because the sample is so small, what must be done to determine if the data comes from a population that is normally distributed? And it's small, and that's the reason why is because N, if you count those numbers, is equal to 10, which is less than 30, which was our magic cutoff number that we needed. And so to deal with this, we are going to look back at section 6.5 notes. And there was 3 things that we had to check. The first one is that you either have 0 or 1 outliers, no more. 2 is going to be if we made a histogram, it's going to be roughly bell-shaped. So is roughly bell-shaped. And then our third one is that if we were to graph our normal quantile plot, so normal quantile plot, and we would see that it is approximately a straight line. So part B says, was the class effective? Use the alpha equals 0.10 significance level. So next thing we need to do is write down H0 and H1. We are dealing with mean reading speeds or average reading speeds, so put mu's for both of these. What Michael had read before, which is what is given, is 198. So putting that down for both our null and alternative. And then we are going to have an equal sign for our null. And we're hoping that this class was effective, meaning that it increased his reading speeds. So greater than 198 here for our alternative. We are going to go to t-test. On our graphing calculator, we're going to go to Stat, Edit, and in L1, enter in all the numbers that you are given. Make sure to double check that you entered these in correctly. Once you're done, I'm going to hit Stat again, go to Test, and then go to T-Test. The difference with this one is because we're given a list of values, you need to make sure that you have data selected on your graphing calculator or your app. So again, data. And from here, mu naught is equal to that 198. Make sure you note that this is a right tail test, so that greater than symbol there is entered. And then go ahead and round your p-value correctly to 4 decimals. From the graphing calculator, we get a p-value equal to 0.0033. And we need to compare this to alpha, which is 0.10. Since the p-value is less than alpha, this means that we are going to reject H0. So from here, we have there is sufficient evidence at the alpha equals 0.10 level of significance to conclude that the class is effective and reading speeds increased. So yes, class was effective. So again, make sure you understand how to deal with this with data and with stats. So entering that raw data into L1, and then like the other examples before they gave us those summary statistics, and entering that in for stats on your graphing calculator. So the last page is a review. There are 2 problems here because a lot of students do really well when these are separated into their sections, but they struggle more when they have to read and really comprehend the problem. And so for this, I would suggest pausing the video here and trying these 2 problems on your own, and then unpausing it and just checking to see if you got them correct. So hopefully you pause the video and you try these on your own, and we're going to walk through them and see how you did. So this first example says, in 2020, 58% of females aged 15 years of age and older lived alone, according to the U.S. Census Bureau. A sociologist tests whether the percentage is different today by conducting a random sample of 500 females aged 15 years of age and older, and finds that 285 are living alone. Is there sufficient evidence at at the alpha equals 0.1 level of significance to conclude that the proportion has changed since 2020. Assume all testing criteria has been met. So we don't need to check anything here. So we are dealing with proportions. So when I write down my null and my alternative, and we'll start off with a P for proportions. And it does say in 2020, 58% of females were living alone. And so this is going to be our population number that we have. Writing this as a decimal, we have 0.58. Your null always gets an equal sign. And they're trying to see if it is different today. So that means that we are going to have a not equals to here. And so we are using proportions. And so in order to do this, we're going to go to one prop Z test. And with that, X is the number of women that are living alone, which is 285. And N, which is our sample, would be 500. On the graphing calculator, we're going to go stat, test, and then one prop Z test. For this, P naught is equal to that 0.58. X is equal to 285. And N is equal to 500. Also note that this is a two-tailed test. Make sure you have that not equals to selected and then round your p-value correctly. From the graphing calculator, we get a p-value equal to 0.6505. And we need to compare this to alpha, which is given as 0.1. And our p-value is greater than alpha. So this means we do not reject H naught. So from here, we do need to write our conclusion. And so we are going to say there is not sufficient evidence at the alpha equals 0.10 level of significance to conclude that, and again, always talking about H1, which is that the proportion of females living alone has changed or is different since 2020. So we have another example right below. And the second one says, a manufacturer claims that its rechargeable batteries are good for an average of more than 1,000 charges. A random sample of 100 rechargeable batteries has a mean life of 1,002 charges and a standard deviation of 14 charges. Is there enough evidence to support the manufacturer's claim at the alpha equals 0.10 level of significance? So for this one, we are dealing with mean. So there is the manufacturer claiming that they are good in the average amount. So checking the requirements as they're not yet checked. These have to be a simple random sample, and N, which is 100, has to be greater than or equal to 30. So check on both of these. The next thing that we would have to do is write down our null and alternative. Since we're dealing with means, I'm going to go ahead and put a mu here for both. And the average that they have, it says that they're testing more than 1,000 charges. So greater than 1,000 charges for our alternative. And our null would be equals to 1,000 charges. And so for this, we are going to use t-test on our calculator. And our mu naught is equal to that 1,000. It's going to ask for x bar, sx, and n. And so x bar is equal to 1,002. Standard deviation is 14, and your sample size is 100. On your graphing calculator, you're going to go to stat, test, and then we're going to go to t-test. For this, we are dealing with statistics that were given to us. So mu naught is going to be 1,000. Select enter. X bar is 1,002. Select enter. S of x is 14, that's your sample standard deviation, and our sample size was 100. Select enter. Also note that we are dealing with a right-tailed test, so make sure you have that greater than option selected. Get your p-value and round it correctly to 4 decimal places. From the graphing calculator, we get a p-value equal to 0.0781, and we need to compare this to our alpha value, which is 0.10. And so our p-value is less than alpha, and so this means that we are going to reject H naught. And from here, we just need to write our conclusion, which is going to be there is sufficient evidence at the alpha equals 0.10 level of significance to conclude that the mean number of charges is, and again, always talking about H1, so is more than 1,000 charges. So this is the end of the chapter 8 notes. So make sure that you scan these in as a single PDF file. Make sure your pages are in order and everything's complete, and then upload them as soon as you can so you can check this off your to-do list.